Okay, welcome back everyone to the second part tutorial of this motion our splines, where last time we were making the pathway and showing you generally how the motion is again, how we are going to actually make the objects move along this path. And this one we're just really going to add the chains. And if you haven't watched the previous, I really recommend that you watch the previous part. It's going to really be helpful to really understand what's going on right now. So we ended up here where I did the icospheres and did the resampling and stuff. So what I'm going to actually do right now is actually delete this part because it was only for demonstration. I'm just going to press Ctrl X, and instead of resampling by count, which is actually better but not actually good as well. So what I'm actually going to do right now, I'm going to set it to length, and this is going to be the length of the chains. So I'm just going to connect this to input, and I'm just going to change this to maybe chain size. Yeah, they're going to be the sizes of the chains. This value is going to determine it. And I'm going to like to print 0.4. I feel it's going to be a little bit better. So what I'm going to do right now is convert this into a mesh, curve to mesh, something like that. And I'm going to sort of duplicate the edges. Okay, so each edge is its own, right? Something like that. And what I'm going to do right now is separate geometry, and I'm going to separate the edges. And how am I going to separate them? It's like a certain module, sort of like even cutting, like a certain pattern that is going to be made. I'm going to mute this structure control. So what I'm going to do right now, I'm going to connect the equals to 0, and here is going to be a float. Here I'm going to connect the math modulated, and we're going to modulate the index. Okay, and we're going to modulate by 2, so the index of these edges will be going, instead of going 0 1 2 and so on, it's going to go 0 1, and it starts repeating again. When it reaches 2, going 0 1 0 1 0 1 0 1, and at this first point I'm just going to select 0. You can select 1 if you want, doesn't really matter. At this point you can type in 1 here, or 0, leave it like me. So I'm going to connect this into the output, and you can see sort of this even even thing that is happening right now. And if I play it, you can sort of see as if the edges are moving. Okay, sort of evenness here, except one, which is over here, and I will explain why. And that's the reason why here, it's because of here. So I want to do this later. I think I prefer to do this later, to demonstrate later in the end. So I'm just going to leave a little bit of space here. Okay, and I'm just going to grab this somewhere there, and somewhere there, just like that. So what I'm going to do right now, we're going to start instancing. Okay, and I'm going to start by adding an instance on points like that. And what we're going to instance is an object info, which is one of these items over here, which are these chains, which I named them as chain 1 and chain 2. In the first case, I'll instant chain 1, and in this case I really uh, tell you to keep it at original. I know we normally add the object info node, set it to relative. I did this before, and you don't want to do that. Just keep it at original and connect it to there, like that. Let me just hide the items now, and now it looks messy. Everything is overlapping, and it just doesn't give the chain vibes. So first of all, I want to point out something. We need to instance on one of the vertices, in every edge. We don't want to each instance on every point, but one vertex in every edge. And the right not to do it, in my previous references, was the edges vertices. So I'm going to add in the edge vertices, which is this one here, and I'm going to connect in here the evaluate domain like that, and this is going to be the domain of the edges, so the information also goes to the points in the end of the day. So I'm going to connect in equal, in B I'm going to connect in the index, and hopefully by doing this I'll have decreased the number of points, and it still doesn't give us those chain vibes, like this thing is a chain whatever. So what we're actually going to do right now is to scale them down a bit. Now by how much are we going to scale? That's the question. Okay, so if you actually open this and maybe map the system, is that this chain has a distance from here to here in the cycles, and that's why I kept the origin. For example, each chain like this one here, its origin is over here, it's this one's origin over here, even actually the distance, the origin is in the middle, and the origin for the distance doesn't really matter. This distance line here, this distance line is the one that I wanted to use instead of going all complicated and stuff, and just wanted to make it simple. I just wanted that distance line to tell me the distance between those 2 points instead of um, finding it myself. Could make it a little bit complicated. So I just actually modeled this, and this cycle that is formed here by chain 1, this one here, the distance between these two cycles is between the same is this line here, and it's the same for this one here. It should be the same, and the origin position to be one of the cycles is also very important in this case. So what are we going to do next is scale them down. Now I'm going to open to see now the system, hiding the items, and there is how we're going to scale everything. So I'm going to duplicate this here. Maybe this one I can change it to relative and keep the distance line. So we're going to do a sample index, and we're going to do sample index of every edge, and here the value will be the distance. And actually we can duplicate this one here, and we're going to do like the distance of these two, then connect it to the value like that. Then we're going to actually divide, okay, and we're going to keep this actually below here, and when it comes to the one on top, it's actually the same, okay, like the original size. Like for example, in this case, if we're instancing on this point, we want the chain to be from here, let me just write from here all the way to here. So we actually need to sort of divide the original size, okay, then multiply by the size of the actual edge. That's why this come in. If we keep it here below, it's like we're actually dividing, then we keep it here, it's like we sort of multiply. It's sort of complicated, but this is how it's done. Okay, it sounds complicated. Then here I'm just going to click in the evaluate domain, and this is the domain of edges, because remember it's edge vertices, this information is mostly in edges, and connect it here in the divide. Then I'm going to connect it into the scale. So hopefully by doing that, if I connect there's there, and now it's giving those chain vibes, right? Like the sign, and you can even assume like this version, it almost looks like an escalator. Okay, it almost looks like an escalator. It doesn't look like an escalator, but it does give some escalator vibes, especially this portion over here. Yeah, so what I'm going to do right now is simply now orient them to be in the right direction. So what we're going to do now is align the rotation, we can say. So the simple, if it's that method, it's actually quite simple to do. It's the same these edge vertices, connect this one, duplicate them somewhere there, send it to subtract. And because here we chose to instance on the first one, index 1, we'll actually have to subtract position 2 from position 1, like that, not the other way around. Then we're going to connect this to the align rotation to vector, and we're actually going to connect this to the vector, and here we're going to like choose the X, because if you these things, the chains are flat, actually not flat, but this, it's along the X, this distance line, and how they're oriented is along the X, and there. And hopefully if I connect this rotation into the rotation there, okay, didn't go as planned. It's because I changed it, instead of writing subtract I kept multiply. And now if I keep it to subtract, now if I play this, it's almost giving those chain vibes that we actually want. You know, everything seems to be all right. Okay, it gives that chain vibe, except over here, and I'm actually glad this happened. And this will, I will explain later in a minute why this happened, whereby every chain, you know, it's all by itself, but here is where we get an intersection. It's actually because of the system of resolution that we kept there, whereby we were resampling by length and not count, and I'll show you why. Okay, so for the other part, because we actually finished with this chain 1, for the other part it's actually the same, it's the same thing, but the only thing that we have to change is the chain, as far as I remember. So Shift A, connect this to the join geometry, grab it somewhere there. Now we're taking this and this, grab it to somewhere on the top, then press Shift Control D, move it down. Now instead of this, the inverted, the selected, keep the inverted. Instead of chain, instead of here in chain 1, when instancing, keep chain 2, make sure it's in original, doing this 2 by join geometry node, keep it there. I can delete this one by Control X, Shift Alt, make sure I enable node wrangler. And now if I play this, you can see that chains join together, feeling that it's coming now, right? So we still have this problem here. We have this part here that's intersecting, and it's kind of uncomfortable watching if it keeps playing, and we have this small part. So how to solve this is actually by resampling. Instead of by length, you resample by count, right? And that count is always supposed to be an odd number, whereby if you write an odd number, no problem happens. And even, there is a problem. Odd, see, that's what's happening. So we can say that we change this, instead of chain size, to be number of chains. It's okay for some people, but for me it's not. I prefer the size of the chains to remain always the same, no matter the case. Okay, so what we're going to do is we're going to resample by count, I mean by length, but the way that the number of points that's going to come out here, we're going to sort of add 1 whenever we get an even number. So what we're going to do is very simple. We're going to connect this to a resample, curve by count, and connect it there, and now they are 10. So what we are going to do right now, we're going to do a sample index, and we're going to do of a spline, and we're going to connect it to, set it to integer, and this we're going to do a spline count, spline length, we're going to do point count, connect this one here to there, and we get back our original. So but we have this problem here, that is always, there's always a hole. So what we're going to do is actually we're going to multiply this, actually we're going to divide this by 2, okay, something like that, and we're going to take the fraction from here. For example, in this case of ours, the value is 0. Okay, if it could be a different number, if it could be equal to, let's say what, 0.5, because in some cases, for example, if I write 0.3, maybe it's going to be 0.5. Some number is going to be 0.4, depending on it's going to be even or odd. So we want that if it's always equal to 0, okay, add 1 to whatever number, whatever amount of points that we're going to get from here. So I'm going to write in here add 1, but under a condition that it's actually equal to 0 in this procedure, because if it's equal to 0 means it's even, if it's equal to 0.5 means it's odd. Okay, so simple like that. I'm going to connect this one here, select all this, grab them somewhere there. So I'm going to connect this one to a switch if it's equal to 0, and connect this one. Actually I have to change this to an integer and check this one to be there in the false, then this one to be in the condition, and keep this one there in the count. And hopefully if I mute this one, Ctrl X, maybe I should switch. And take this one somewhere there. Okay, something seems not to be right. Okay, I get it now. We are right at the first time. The thing is, instead of adding 0.5, it should be added 1. And now if I look from the top and maybe select this and maybe write 0.6, no matter the and play this, no matter the number that I write here, maybe I can write 0.7. There will never be a hole, okay, unless you want it yourself. And yeah, simple like that. Now we have some chains moving, and I can increase the speed as usual, give it to 4. I don't like that it's moving in the clockwise direction. Change it to negative, -4. It's now it's moving anti-clockwise. It's moving too fast, -1, like that. Simple as it is. And that will be the end of this part, because yeah, actually, because everything is now done. The only thing is that we need to add the wheels, so that these things to be seen as if they are controlled by something else, like the wheels are the one that is controlling this thing. So yeah, let me see you in the other part, which is the last part, will be part 3. Hopefully you'll join me in this series, as I'm going to be adding the wheels. If you like what you're seeing, please consider liking, subscribing, commenting what you want to see in the future, to try out, and thank you for watching till here. Have a nice day.